This is lesson 2.3, which talks about deductive reasoning. So, what is inductive reasoning? So, deductive reasoning is logical reasoning. In other words, it's the process of reasoning logically from given statements to a conclusion. So this is like what lawyers do. This is what you do when you argue with your mom and dad as why you're trustworthy enough to go to the movies with your friends, etc., etc. And in mathematics, there are a couple different ways of looking at this logic to make it a little bit easier on ourselves. There are two big laws that we need to know about, and we're going to talk about them right now. Okay, so the very first law is called the Law of Detachment. And the way that the Law of Detachment works is very finicky, so you have to be very careful. If a conditional is true and the hypothesis is true, then its conclusion is true. And below here with a little asterisk, this is just how it would look in symbolic form if I were to write it out. If P then Q is true, in other words, if a conditional statement is true, and P is true, which is the hypothesis, then Q is true, which is the conclusion. So, let's take a look at a specific example and see if we can use this adequately. Okay, so here's some information. You will always be given a conditional statement and then another statement right after it. So the first statement is our conditional statement, which we have to determine is true if it is snowing and the temperature is less than or equal to 32 degrees Fahrenheit. That's a true statement. Okay, so we have taken care of the if P then Q is true. So I'm going to check mark this part off. The next part is that P has to be true. Well, if it is snowing. Okay, so first of all we have to know that it's snowing outside in order to make this conclusion. Okay, if that is the case, then I know that the temperature is less than or equal to 32 degrees Fahrenheit. That's my conclusion, and I have to determine that that's true. Okay, so I can check this mark off here on my list. However, the hypothesis part has to be stated in order to draw that conclusion. So regardless of if I know if the temperature is 20 degrees or not, the hypothesis of this statement is not understood to be known right now. I don't know if it's snowing outside. Not that it ever would in Texas. But if that part is not shown to be true, if this part is neglected, then I can't draw a conclusion at all. So my conclusion here is that there is no conclusion. I cannot determine whether it's snowing or not. Just because it's 20 degrees outside doesn't mean that there's snow falling from the sky. Let's take a look at another example. Alright, so here's our second example. So if M is the midpoint of a segment, then it divides the segment into two congruent pieces. So the statement after that I want to try to draw a conclusion from is that M is the midpoint of segment AB. First of all, let's determine what's true. My conditional statement is a true statement, so this part is good. Now, in the second statement, I want to be able to determine this part again. Is P true? So do I have information that connects this bottom statement to the hypothesis? And the answer to that is yes. This tells me that M is a midpoint of a segment, and the hypothesis appears that M has to be a midpoint of a segment. Since I'm given the hypothesis and I know it to be true, then I can determine the conclusion of this, and that is that Q has to be true, which is whatever conclusion was stated in the conditional statement. And in this case, the conclusion would be it divides the segment into two congruent pieces. So that would be my written out conclusion right here in blue. Okay? So that's how the law of detachment works. We have one other law, which is called the Law of Syllogism. Okay, so the Law of Syllogism is actually used a whole lot more than the Law of Detachment. And it says that if P then Q, so that's a conditional statement, and Q then R, that just means it's another conditional statement. and both of these happen to be true, then P then R is true. Let's take a look at an example and see what this means. All right, so here are our two statements, our two conditional statements. The first one is P then Q. So if a number is prime, then it does not have any repeated factors. So let's determine if that's true or not. That is definitely true. The only factors a prime number should have are 1 in itself. Then the next statement, this is my Q then R. If a number doesn't have any repeated factors, then it is not a perfect square. That is actually true. I'm not sure if you knew that or not, but that is a true statement. So let's take a look at the rules here. Look back up at the top. It says first that P then Q. Now this Q is the same exact Q as this. So in order for this to work, the conclusion of my first statement, it does not have any repeated factors, must be the hypothesis of the second statement. So they kind of overlap each other, okay? So if that happens to be true, then we can make the conclusion right away that P then R. So P was the hypothesis of my original statement. So I'm going to write that down. Okay, if a number is prime, that was that P part, okay, right here. Now the next part says, if P then R. Well, R was the conclusion of my second statement, which is, then it is not a perfect square. So there we go. So I can make a conclusion, in this case, by simply skipping the middle information, because it wasn't necessary. If I know a number is prime, which doesn't have any repeated factors, then I know it's not a perfect square because of this information. So it's kind of nice to write it this way instead, because it's just a little bit shorter than writing out both statements at once. So if a number is prime, then it's not a perfect square. So that's how the law of syllogism works. And that concludes this tutorial.